Hi students, welcome to ACE Online. In today's section we are going to discuss about some of the multiple choice questions which concerns to RRB JE point of view, that too physics and chemistry. Right, so this is the second section for physics and chemistry point of view, right. So here guys we are providing some of the expected questions, that too in depth manner. That's why you have to follow the each and every concept, and you should also note down some of the important constants what I explained here. Okay, right. So here it is, the first question. The force that a neutron exerts on a proton inside an atom is, so tidal force, gravitational force, electrostatic force and nuclear force. Nuclear force. Actually guys, if you consider an atom, okay, if you consider an atom, it has nucleus. In this nucleus, neutrons, protons, next here we have electrons. So these three particles are called as electron, proton, neutron. These three particles are called as primary. So primary particles of an atom. Primary particles of an atom, right. So here electrons exhibit negative charge, protons exhibit positive charge, and what about neutron? Neutral in nature, it does not having any charge, no. So but here if you observed in nucleus, mostly protons are existed. So what kind of charge it has? Positive. So we already know that according to Benjamin Franklin, if you consider like charges means plus plus or minus minus. So what kind of forces are always existed between like charges? Only repulsive. Okay, so repulsive forces. Okay, repulsive forces. Here also nucleus should exhibit repulsive forces. Okay, mostly if it exhibit repulsive forces, then what will happen? The stability of the atom mostly be not possible. Okay, why? Because if protons are, let's consider here one proton is also there. Okay, so between these two protons mostly repulsive forces are mostly be existed. So due to that, the stability, it impacts on the stability of the atom. So finally this atom should not be existed, but mostly we have 118 elements in the periodic table. How these elements are mostly be existed to overcome the repulsive forces of repulsive forces of liked ions or liked charges. Okay, so that is nothing but, here we have one of the strongest force in the universe, that is nothing but nuclear force. Nuclear forces. So finally guys, in this universe we are having four forces now. One is nuclear forces of attraction, Next, second one is nuclear forces of repulsion, Next, third one is electrostatic forces, electrostatic forces. Next, fourth one is gravitational forces. Okay, so gravitational forces. Okay, right. So among these four forces, which is the strongest one? Of course, nuclear forces of attraction. Okay, so nuclear forces of attraction is considered as the strongest force in the universe. What about the next one? So electrostatic forces. Next one, nuclear forces of repulsion. And the last one is gravitational forces. So finally guys, here you have to remember 2 points. So in this universe, which is considered as the strongest force? Nuclear forces of attraction. Which is the weakest force? Gravitational forces. So here mostly in nucleus, what kind of particles are mostly be existed? Protons, at the same time neutrons, but the charged particle is only proton. So between protons always exhibit repulsive forces, na? So to overcome repulsive forces, here it has one of the strongest one, that is nothing but nuclear forces of attraction. So that's why here the conclusion is option D. You have to remember almost all these three concepts. So nuclear forces, next the strongest forces of nuclear forces of attraction, weakest forces of gravitational forces, and the same time what are the primary particles of an atom? Electron, proton, neutron. In these three things, which one is not exhibiting any charge? Only neutron. Okay, right. So this is the next question. So zinc can displace copper from copper sulfate solution because zinc is Okay, so because zinc is, right, so more reactive than copper, less reactive than copper, more oxidized than copper, so less oxidized than copper. So for this type of concepts you have to remember standard reduction potential, standard reduction potentials, standard reduction potentials. Okay, right. So it means, guys, based on hydrogen, here we classified two types metals. We classified the total number of elements in the periodic table into two types. One is highly reactive and the second one is mostly less reactive. Highly reactive elements are always existed above the hydrogen. Mostly here let's consider some of the examples. So zinc, next nickel, so next cobalt, next sodium, potassium, next highly reactive one is lithium, next iron, okay, so manganese, so next one iron, manganese, next one cadmium, okay, so cadmium, number of elements are there, so let's consider some of the examples only. Next, so here around we have more than 25 elements, okay. It's not easy to remember almost all these derivatives, na. So lead, okay, so lead, Pb, next tin, so it is not easy to remember almost all these elements, but below this hydrogen we have only 5 metals, okay, so less number of metals are there. So one is copper and the second one is mercury, okay, so mercury, Hg. Second one is mercury, next silver, next gold, next platinum. Okay, right. So what is the importance of this this standard reduction potential values? Guys, here you have to look at it once. Above the hydrogen, these are all having negative SRP values, okay. So its values would be negative. It means these are all reducing agents, reducing agents. It means highly reactive, okay. So what about below hydrogen? So hydrogen value would be here, hydrogen standard reduction value would be 0. So below hydrogen mostly we have copper, next silver, gold, copper, silver, gold, these three are called as noble metals. Next mercury and platinum. So these 5 metals are having positive SRP values, no, its values would be positive. Mostly these are considered as oxidizing agent, oxidizing agents. So finally here the concept is these are less reactive but these are more reactive. These elements can easily replaced by almost every element of the reducing agent, na? Every element which is existed about the hydrogen, okay. So here also same thing. So zinc, here it is, zinc. Next, when reacts with copper, it means if you consider copper sulfate, so this copper can easily replaced by highly reactive metal, nothing but zinc, ZnSO4. Finally here we can get copper. Not only zinc, if you consider iron, okay, or nickel or sodium or potassium or manganese or tin, whatever it is, okay, above the hydrogen almost all these derivatives or all these metals are exhibiting highly reactive. That's why it can easily replace the zinc, next silver, next Rm, whatever it is, okay. So that's why, guys, here the correct option is zinc can displace copper from copper sulfate solution because zinc is more reactive than copper, Option A is the right answer. Next one, which is correct in the following? Ammeter in parallel and voltmeter in series are connected. Next, ammeter in series and voltmeter in parallel are connected. Next, ammeter and voltmeter both are connected in series when the voltage is small. Next, ammeter and voltmeter both are connected in series when the voltage is very high, very large. So what is the correct option here? Anyone? Yes, so what is the correct option here? So if you know the answer, please respond. Option B, ammeter in series and voltmeter in parallel, right? Of course you are right. So option B is the correct one. Okay. So ammeter is in series, next voltmeter is always connected in parallel, okay, connected in parallel. So what is the advantage of ammeter? Ammeter, it can be used to measure the flow of current. Next, what about voltmeter? Right, so voltmeter, it can be used to measure the potential difference. So potential difference. Okay, right. So if you consider ammeter, so that to ideal ammeter, okay, ideal ammeter, its resistance, this is also very important. So what is the resistance of ideal ammeter? Resistance of ideal ammeter, it is always 0, So next, why should we connected ammeter in series? Why? Because to measure the flowness of current, we have to connected, okay, so we have to connected in the direction of flow of electrons, in the direction of flow of electrons. So mostly electrons direction, let's consider in this orientation. So that's why to measure its flowness, we have to connect always in the series only, So that's why guys, here ammeter is always connected in series. Next, voltmeter, to measure the potential difference, it means any 2 points of the circuit, mostly we have to use voltmeter. Okay, right. So what about the resistance of ideal voltmeter? Ideal voltmeter, its value would be always infinity. So these two are also very important in your examination point of view. So here guys, finally the conclusion is option B. So ammeter is always connected in mostly in series, and voltmeter always connected in parallel. So this is the correct one. Okay, right. So next one, give an example of a salt which gives an aqueous solution of pH less than 7. Right, ammonium chloride. Next one, sodium carbonate. Next, sodium bicarbonate. So next one, sodium chloride. So pH less than 7 means acids. Okay, the chemical should be exhibit acidic in nature. So then only its pH value is considered below 7 only. Right. So ammonium chloride, its formula would be NH4Cl. Next, sodium carbonate, its formula Na2CO3. Next, sodium bicarbonate, NaHCO3. Sodium chloride, NaCl. Almost these are all considered as salts. That's why first we have to analyze about the nature of salt. Then only we can conclude whether it is acidic or basic. So in this, the first one, NH4Cl. If it is get into dissociated, then we get mostly NH4 plus and Cl minus. This is cation, right? And this one is anion. So NH4 plus. If you add hydroxide ions, so then what we get? NH4OH. Next, if you add H plus ions, here what we get? HCl. Actually HCl is a strong acid and NH4OH is a weak base. If you add weak base with strong acid, finally what kind of salts we get? Acidic nature salts. Why? Because here the salt this one is having mostly strong acid, because of that the resultant chemical nature would be acidic. Okay, so acidic, it means its pH value should be less than 7 only. What about sodium carbonate? Na2CO3. If it is dissociated, then we get Na plus and CO3 minus 2. If you add OH minus, then we can get NaOH. Here if you add H plus ions, mostly here it forms H2CO3, carbonic acid. This is a strong base. NaOH is considered as strong base. What about carbonic acid? So this is treated as a weak acid. So finally, the resultant salt nature would be mostly basic. So basic means its pH value greater than 7 only, greater than 7 only. Right. So next one, sodium bicarbonate. Okay, sodium NaHCO3. So if you dissociated this molecule, then what we get? Na plus and HCO3 minus. If you add hydroxide and H plus ions, finally here it forms sodium hydroxide, strong base, and carbonic acid, H2CO3. This is weak acid. So here guys, which one is mostly highly concentrated? Base, na? So that's why the resultant salt would be basic in nature. It means pH value greater than 7, not less than 7. And the last one is sodium chloride, NaCl. So if it is dissociated, then it can form Na plus and Cl minus. If you added corresponding hydroxide and H plus ions, finally we can get NaOH, strong base, next and H plus Cl minus. What we get? HCl. This is strong acid. So strong base and strong acid. So the resultant salt would be mostly neutral in nature. Neutral means its pH value equal to 7. Okay, so finally here the conclusion, its pH value equal to 7, this is greater than 7, this one is greater than 7, but this one is only less than 7. Here they are rising about pH value less than 7. So that's why we have to consider option A is the right answer. Okay, option A. Right, so next one, the radius of the orbit of geostationary satellite is, the radius of orbit of geostationary satellite. So geostationary satellite means it always revolving around the earth based on the equator. Okay, so based on the equator, it always revolving on the equator. Okay, right, equator. That too at what altitude? Mostly what is the radius of the earth? 6,000, approximately 6,400 kilometers. 6,400 kilometers. Next, geostationary satellites are mostly injected at the altitude of 36,000 kilometers. Okay, from the equator, mostly these type of satellites are placed at the altitude of 36,000 kilometers. Exact value is 35,786 kilometers. 86 kilometers. Next, here the radius of the earth is around 6,400 kilometers. Na? So finally, from the center of the earth, so mostly geostationary satellites are placed at 42,400 kilometers. 42,400 kilometers. So that's why guys, here the correct answer is option C, 42,000 kilometers. 42,000 kilometers. Option C is the correct answer. Okay, right, next one. The pair of stable covalent molecules in which the central atom is not obeying the octane rule. Okay, so here they are rising about which molecules, which kind of molecules are mostly not exhibiting octane rule. First of all guys, octane rule means octane rule. Rule means mostly it exhibit, okay, its valency electrons, valency shell electrons are completely filled. Valency shell electrons or valency shell orbitals should be completely filled. Should be completely filled. So completely filled. Then only those type of atoms can exhibit octane rule. Let's consider one example, methane. Okay, so methane, here its formula CH4, right? So CH4, carbon consists to which group? Mostly fourth A group, or its atomic number 6, 1s2, so 2s2, 2p2. Okay, here in s orbital it has 2 electrons, in p orbital it has same 2 electrons. So when it absorbs some energy, mostly this electron, 2s electron, jumped into 2p orbital. Finally, here we can get this type of electron orientation. Okay, so in valency shell, how many unpaired electrons are existed here? This is excited state and this is ground state. So in excited state it has 4 unpaired electrons, that's why it can form 4 bonds. Suppose if you consider in ground state it has only 2 unpaired electrons, due to that it can form only 2 bonds. But so if you consider methane, carbon is connected with 4 hydrogens, due to that here carbon electron configuration is treated like this, Next here how many hydrogens are surrounded with carbon? 4 hydrogens. So we already know that carbon is having 4 valency electrons like this, 4 valency electrons. Next it is bonded with hydrogen. Each hydrogen is having 1 electron like this, 1 electron. So finally here how many electrons are there? 2. Next here 2, next here 2, next here 2. Totally how many electrons? 8 electrons. It means it obeys the octant rule. Okay, if the valency shell is mostly maintained 8 electrons or 18 electrons, these are considered as, okay, if it is maintaining 2, 8, 8, 18, 18, 32, these are considered as magic numbers. Suppose if any molecule, if you consider any molecule, if the central metal should be maintain this much number of electrons, either 2 or 8 or 18 or 32, whatever it is, then its stability would be very high. Then it obey the octant rule. Okay, octant rule means not only 8 electrons, if it is having 18 electrons or if it is having mostly 32 electrons are also exhibiting more stability, right? So that's why, so CH4, okay, so CH4 methane exhibiting octant rule. Next carbon tetrachloride CCl4. So here also carbon is connected with 4 chlorine atoms. So each chlorine can donate 1 electron, and each carbon can also share 1 electron. Finally it has 8 electrons in its valency shell. Next beryllium halide, so BeCl2. If you are following this method, it is completely time consumption, completely related to time consumption. That's why here I mentioned one of the shortcuts. So based on that you can easily solve that one. So this is the shortcut. CH4, carbon which group? 4th A group. Next hydrogen which group? Mostly first group. So here how many hydrogens are there? 4. So that's why 4 into 1. Finally what we get? 8 electrons. It means it obey the octant rule. Next carbon tetrachloride CCl4, carbon which group? 4th group. Okay, so 4th group. Next 4 into how many chlorines we have? 4 chlorines. So next each chlorine in its valency shell it has 7 electrons. It means it concerns to 7th group. So 28 plus 4, that is equal to 32. 32 means it obey the magic number electron configuration. That's why it is also follow the octant rule. Next one beryllium chloride. Beryllium concern to 2nd group. Chlorine, so chlorine concern to 7th group. Okay, so finally here 14 plus 2, 16. It means it does not obey the octant rule. Next one boron halide. Boron halide means BCl3 like that. Boron concern to which group? Mostly 3rd group. Okay, so 3rd group. Next chlorine concern to 7th group. Okay, so 21 plus 3, 24. It means it does not obey the octant rule. That's why guys, option B is the right answer. What about remaining molecules? Ammonia, NH3. Nitrogen concerns to 5th A group. Okay, 5th A group or 15th group. Next hydrogen concerns to 1st group. So finally here we get 8 electrons. Next one water, H2O. Okay, hydrogen 2 into 1. Oxygen 16th group or 6th group, 6th A group. So finally here we can get 8 electrons. Next one carbon dioxide. If you consider carbon dioxide mostly guys, here it has 4 bonds. Carbon exhibit 4 bonds, means here 2, here 2, here 2, here 2. Totally how many electrons? If you consider a bond, it has 2 electrons, right? So totally how many bonds it has? Mostly 4 bonds. 4 into 2, that is equal to 8 electrons. It means it obey the octant rule. Next acetylene molecule is considered like this. So here it is the central atom. So here 1 bond is there. Here it is attached with 3 bonds. So totally 4 bonds it has. 4 bonds means 8 electrons. So that's why here except B remaining all the molecules can exhibit the octant rule, na? So that's why option B is the right answer. Okay, right, the moon is revolving around the earth with a certain angular velocity. What happens if the velocity becomes 0? What happens if the velocity becomes 0? It means, guys, so if let's consider moon. Moon has its own axis. Based on that, it always revolving itself. So the time taken to revolving itself, it takes mostly, okay, the time taken to revolving itself, it take mostly it concerns to around how much time is needed to complete one rotation around itself? Mostly 27.4 days. 27.4 days. So the moon is revolving around the earth. Next, in the same manner, okay, so it all first of all it is self-rotating. Next, in the same manner it is also revolving around the earth, revolving around the earth. So what did they mention? Suppose if the velocity becomes 0, means if velocity becomes 0 means, okay, actually let's consider this is the orientation of moon, this is the earth. If the velocity becomes 0 means it is moves towards straight line, okay, nothing but tangent of the orbit, okay, tangent of the orbit. If the velocity would be 0, it is not easy to revolving around the earth, na? So to revolve around the earth, it should exhibit centripetal force, means it should maintain at least some velocity, okay. So that is considered like orbital velocity. So here they mention the velocity would be 0, then option 4 is the correct one. The moon moves along the tangent of its orbit, okay. So tangent of its orbit, so like this, tangent of its orbit, it's completely deviated from the orbit only, na? So mostly angular velocity W is equal to delta t by t. So here delta theta indicate angle, next t indicates mostly time. So this is angular velocity. Next one, element A has electronic configuration 2, 7. So you have to observe carefully. So element A has electron configuration 2, 7. It means it concerns to 7th group. 2, 7 means 9 electrons. 9 electrons means it already crossed the helium noble gas configuration, na? So helium, next neon, next argon, next krypton, next xenon, next radon, next oxygen. Helium, electron configuration 2, atomic number 2, neon 10, argon 18, krypton 36, xenon 54, radon 86, oxygen 118. So here the atomic number is mostly 9. 9 means 2 plus 7, right? So 2 plus 7. It means helium plus 7 electrons. 7 electrons means it concerns to 7th A group, okay? So 7th A group. So which is the first element in 7th A group? Of course fluorine, okay, fluorine. Next one, next B. B has configuration 2, 8, 6. It means the total number of electrons are 16. 16 means 10 plus 6, okay. So it already crossed the noble gas neon. That's why here we should consider like neon plus 6 electrons. 6 electrons. It means in its valence shell, how many electrons are there? Only 6 electrons. It means it concerns to 6th group, 6th A group, okay. Next one C. C has configuration 2, 8, 8. 2, 8, 8. So totally how many electrons? 18 electrons. 18 electrons means nothing but argon, okay. So argon, it is completely equal to argon, nothing but 0 group or 18th group. Next one D. So D has 2, 8, 7. 2, 8, 7. So totally 10 plus 7. 10 plus 7. 10 means neon, 7 electrons in its valence shell. it means it concerns to 7th A group. So here guys, they are rising about which element shows similar chemical properties. To exhibit similar chemical properties, those elements should be exist to one group. Then only those elements properties are almost similar. So here the first one concerns to 7th group, and the fourth one nothing but D, element D concerns to 7th group. So that's why A comma D, option A is the right answer. These two are having similar properties. So to attempt RRB JE examination, first of all guys, you have to by heart group numbers. Okay, so groups and concerned elements. So just like this, first group, this is called as alkali metals. Okay, alkaline metals. So hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Next, alkaline earth metals, nothing but second group elements, beryllium, magnesium, calcium, strontium, barium, radium. Next, 13th group or third A group, boron, aluminium, gallium, indium, thallium, nihonium. Next one, 4th A group, carbon, silicon, germanium, tin, lead. Next, flavorium. Next one, 5th A group, nitrogen, phosphorus, arsenic, antimony, bismuth. Next, moscovium. Next one, 6th A group, oxygen, sulfur, silurium, tellurium, polonium, livermorium. Next, 7th group, fluorine, chlorine, bromine, iodine, acetine. Next, tennessine. Okay, so last one, helium, neon, argon, krypton, xenon, radon, oxygen. Okay, so you have to by heart in this manner. So then it is very easy to attempt at least 3 questions, especially in RRB JE point of view. Not only RRB JE, if you attempt RRB group D or RRB related examination, if it is having any general science, that too chemistry related concepts, definitely you can get some of the questions especially from this periodic table. That's why you have to by heart in group wise. Okay, so especially these 2 groups, at the same time these 6 groups, these are very important in your examination point of view. They directly rise which one of the following is not considered as a halogen. Okay, so option A, hydrogen, option B, chlorine, option C, bromine, option D, acetine. Mostly hydrogen. If you know the group elements, then only you can attend the then only you can get the answer, otherwise it's not easy. That's why you have to by heart almost all these things. Okay, you have to by heart almost all these things. It's very easy. So in this orientation, you have to by heart. It definitely helpful for your examination, especially in RRB JE. You can get at least 3 questions from this periodic table point of view. Okay, yes, directly or indirectly you can get 3 questions. So finally here the conclusion is option A. Right, so the next one, in photoelectric effect, the magnitude of stopping potential increases with the magnitude of stopping potential. So before going to that, what is meant by photoelectric effect? So photoelectric effect, right. So actually this concept was introduced by Einstein. Of course he was awarded with the Nobel Prize also. Einstein proposed number of concepts. In that, one of the derivative is photoelectric effect, and the second one is relative theory. Okay, so relative theory, nothing but E is equal to mc square. In these 2 things, Einstein got the Nobel Prize because of the introducing of photoelectric effect. So what is the importance of photoelectric effect? How a material can get the color. Suppose if you consider this material, okay, so this material, when a white light incident on it, then it shows red color. Suppose absence of light, no one can guess the color of this material. How it emits? How does it emit? Mostly red color. Let's consider one of the particle in that. Okay, so here it is. So this is one of the atom of the material. When a light is incident on it, okay, let's consider the energy of this incident light would be mostly 4 calories. In this, half of the energy, nothing but 2 calories, energy is required to mostly to jump this ground state electron from lower energy orbital to higher energy orbital. Okay, so here what here my conclusion is, first half of the energy of instant light mostly considered by the valency electron. Okay, so and that energy is utilized to prepare to jump from lower energy to higher energy. Next, remaining 2 electrons. So first it consumes 2 calories to ready to jump the higher energy orbital. Next, remaining 2 calories are also be absorbed. So then finally it jumps to higher energy orbital. Okay, so after consuming of 4 calories, now the electron is mostly displaced at here. So actually this is not the exact position of the electron. Actually it comes from lower energy. That's why especially at this higher energy orbital it stay around minus 10 power 13 seconds. After that it again jumped into lower energy orbital. So what happened, from lower to higher it absorbed the energy, from higher to lower it releases the energy. The released energy is exhibiting the concerned color. Okay, so mostly here that material exhibit red color na. Why? Because the particles it means nothing but the valency electrons are absorbed some of the energy from the instant light and it emits only red color. Due to that mostly it exhibit red color na. So this type of phenomena actually introduced by Einstein. Okay, right. So here they are rising about the magnitude of stopping potential increases with. So here stopping potential is always directly proportional to mostly incident radiation. Okay, stopping potential is always directly proportional to incident radiation. You have to remember this one. So it means if the stopping potential increases, then incident radiation is also increases. Because of that, here the correct option is option D, increases of the frequency of incident radiation. So what is meant by stopping potential? Stopping potential means the amount of potential that is required to stop the electron. Okay, the amount of energy or mostly the amount of potential is required to stop the electron having maximum kinetic energy from moving. Is known as stopped potential. So this stopped potential is always directly proportional to the kinetic energy of the directly proportional to the frequency of incident radiation. So this is the exact equation to represent the concept which concerns to magnitude of stopping potential. So here guys, Kmax is nothing but kinetic energy, which is equal to E into V naught. E means electrons, next V naught is considered as stopping potential. Here kinetic energy is always directly proportional to the stopping potential na. If we increase the frequency, then what will happen? Mostly incident radiation will also be increased. Okay, right. So next, identify the isoelectronic pair from the following. So here they mention fluorine atom, nitride ion, next fluoride ion, oxygen atom, next one neon atom. Okay, right. So isoelectronic means same number of electrons. Same number of electrons. Okay, right. First one, fluorine atom. Fluorine atom means like this. How many electrons it has? 9 electrons only. Next, fluoride ion. Fluoride ion means F minus. Okay, if it is having negative charge, then the suffix is termed with IDE, ide. Okay, so generally F is called fluorine, but F minus is called fluoride. Cl is considered as chlorine. Cl minus is considered as chloride. Why? Because it has negative charge. Okay, right. So here negative charge always indicates gain of electrons. How many electrons are gained here? Mostly 9 plus, here the charge is minus 1, that's why you have to add 1 electron. Finally 10 electrons it has. Next one, nitride ion, N minus 3. Nitrogen atomic number 7. Next, here it has 3 electrons. 3 electrons are gained by nitrogen. Due to that, the total number of electrons are 10. Next, oxygen atom. Okay, oxygen, O. So here it has 8 electrons only. Next, neon. Its atomic number 10. So finally, fluoride, next nitride, next one neon. These three are having same number of electrons. Okay, so 2, next 4, next 5, 2, 4, 5. Option B. Option B is the right answer. Okay. Right. So next one, assertion. So if a body moving in a circular path has constant speed, then there is no force acting on it. Reason: the direction of the velocity vector of a body moving in a circular path is changing. Yes. So what is the, okay, first of all guys, if you consider assertion, what did they mention? If a body moving in a circular path, so this is the circle, here it is the body, okay, here it is the object, moving in a circular path with constant speed, then there is no force acting on it. So this statement is completely wrong. Why? Because if an object is revolving in a circular orbit, okay, revolving in a circular orbit, so then what will happen? One force always act towards the center, that is considered as centripetal force. Okay, so centripetal force, right? So on this object, a force is exerted on it. Now, which one it is? Centripetal. But what did they mention? There is no force acting on it. So that's why assertion is wrong. Next, so reason: the direction of the velocity of vector of a body moving in a circular path is changing. Yes. So actually it always try to move towards a line path, but because of the existence of, okay, because of existence of centripetal force, so its orientation would be just like angular. So mostly if it is not maintaining any angular velocity, then it means if the velocity would be 0, almost this object maintain linear path, but it is not exhibiting that. Na? Why? Because it is revolving in a circular path. So what is the reason behind that? Centripetal force. So that's why here A is wrong, but R is correct. Okay, A is wrong, but R is correct. So it always try to move towards a linear path, but one of the force exerted on the object, due to that it is revolving around the center of the derivative, center of that circular derivative. So that's why guys, here we have to consider option A is the correct one. The next one, which of the following three elements have filled outermost shell? Filled outermost shell. Which of the following three elements have filled outermost shell? Okay, so magnesium, helium, neon. So magnesium, okay, so its atomic number 12, means 1s2, 2s2, 2p6, next 3s2, okay. So here a valency shell is having 2 electrons, but here the n value, principal quantum number is 3, na? So it means it has 3p 3d orbital, but these 2 are completely vacant, but they are rising about. Outermost shell should be completely filled. That's why this one is wrong. Magnesium is wrong. Okay, magnesium is wrong, but helium valency shell electrons are completely filled. Next neon electrons are also completely filled. Why? Because these are all concerns to 8th A group element or 18th group element. So one is wrong. Next one, magnesium, calcium, barium. Of course we already know that magnesium not exhibiting any completely filled configuration, na? So magnesium, calcium, barium, these 3 elements are concerns to second group, mostly first group, second group, okay, except 18th group. Remaining elements should not filled with should not be completely filled with electrons, na? That's why if you know the group number, you can easily get the answer. Lithium concerns to which group? First group. So next sodium, first group. Next potassium, first group. It means it does not completely filled with electrons. Next option D, helium. So 18th group, neon 18th group, argon 18th group. So that's why option D is the right answer. So here it is, option, okay, mostly if you considered 8th A group or 18th group elements, these atoms, these valency shells are completely filled with electrons because these are all noble gases. Right, so next one, 500 ml of water at 40 degrees centigrade mixed with the same quantity of water at 70 degrees. The resultant temperature is, the resultant temperature, okay, resultant temperature T is equal to, so V1 T1 plus V2 T2 by V1 plus V2. This is the formula. Okay, so here they mention, so V1 is equal to 500 ml, 500 ml. Next T1 temperature is equal to 40 degrees centigrade. Next mixed with the same quantity of water. Same quantity means, so here V1 value, V1 volume would be 500 ml na, so V2 is also 500 ml. Next one T2 is equal to 70 degrees. So then what about the resultant temperature? So resultant temperature T is equal to V1 into V2. It means 500 into 40 plus V2 500 into 70 by V1 plus V2, 500 plus 500. So finally what we get here, 2000, next 3500, no, 5500 by 5500 by, so 1000. Okay, so mostly 1000, sorry, 55,000 by 1000. So finally 55 degrees. Option B is the right answer. Resultant temperature is considered as 55 degrees. You have to remember this formula. Right, so next one. Which of the following is not a sublimable substance? First of all, sublimation means solid directly converts to gas without formation of liquid. That process is called as sublimation. Mostly, what kind of chemicals are existed in sublimation process, exhibiting sublimation process? Mostly ammonium chloride, ammonium bromide, ammonium iodide. Okay, ammonium bromide, this is ammonium iodide, ammonium chloride. Next menthol. Okay, so menthol. Next camphor. Okay, next one naphthalene. Next anthracene. Okay, next one mostly dry ice. Okay, dry ice. Next one sleeping pills. Nothing but mercuric chloride, HgCl2, mercuric chloride. Next sodium benzoate. This is the food preservator. This is the most commonly used food preservator. Next iodine. Okay, iodine. These iodine vapors are mostly be used to collect fingerprints, especially by clues team na. So finally guys, these are the major chemicals which exhibit sublimation process. It means if it is heated, if you consider any chemical from here, if it is heated, it directly converts to gas without formation of liquid. That's why, so naphthalene, camphor, ammonium chloride, this is also called as smelling salt. In narcotic analysis, mostly these type of salts can be used. Okay, right. So here, which one is not participated in sublimation process? Option A. Option A is the right answer. Okay. Next one. Doctors advised 2D lens for a person for a good vision. What is its focal length in centimeters? So focal length. Optical power P is equal to 1 by F. 1 by F in meters. 1 by F in meters. So this is the optical power. Optical power or power of opticals. Optical power mostly indicates with P. P is equal to 1 by F. 1 by F. So here guys they mention what are the units of optical power? Diopters. Okay, so diopters. It indicates with D. So here they mention P value. P value is 2D. 2D. So that's why here you have to mention 2. 2 is equal to 1 by f, the 2 in meters. So f is equal to, okay, focal length f is equal to mostly 1 by 2. Then what we get? 0.5. 0.5. So these are meters, na? Here we get in meters. So 0.5 meters. What about in centimeters? F is equal to 50 centimeters, na? So that's why guys, here the correct answer is option B. Option B. And you should also remember that here optical power value would be 2D. 2D means, is it concerns to metropia or is it concerns to myopia or hypermetropia? Here optical power is positive, na? If it is positive, mostly the lens are convex lens. Convex lens are mostly used for hypermetropia. Next, if the value is negative, okay, if the optical power value is negative, so -2, then what kind of lens are being used? Concave lens. Concave lens. Concave lens optical power is always negative. Next, if we wear concave lens, mostly it's, that one is caused by, okay, sorry, that one is majorly used for reduce myopia. Here it is, myopia. Next one, hypermetropia. So this is the normal vision. Let's consider this is the eyeball, and here it is the retina. If you consider an object, this image should always focus on the retina, that too in inverted manner. Okay, so but here if anyone facing myopia means near objects are visible, far objects are not visible, then focal length. Okay, actually the image should be focused on retina, but if anyone is facing myopia, mostly image is focused before the retina. It means focal length mostly decreases. Okay, actually this is the position of the image, but here image is placed at here, not on the retina. It means the focal length value mostly be reduced. These are the most important questions. Next one, hyperopia or hypermetropia. Okay, hyperopia or hypermetropia or presbyopia. Yes, so mostly here if anyone suffering with hyperopia, mostly image is placed behind the retina. It means focal length mostly increases. Okay, so focal point mostly increases. These type of questions are also mostly be raised in your examination point of view. That's why guys, you have to remember importance of diopters. Suppose if the value is positive, it what kind of lens mostly be used? Concave lens or convex lens. If we wear concave lens, the concerned person is facing what kind of vision defect. Okay, so these are all very important in your examination point of view, na? So the next one, when phenolphthalein is added to vinegar, the solution becomes, okay, so phenolphthalein. So phenolphthalein, okay, phenolphthalein. The pronunciation should the correct pronunciation is phenolphthalein. Okay, right. So this is one of the indicator. Okay. Yes, so in presence of acids, mostly it does not exhibit any color. Actually, its color would be colorless. In presence of acid, mostly colorless. Next, but in presence of base, phenolphthalein color turns to pink. So if you observed ACB, Anti-Corruption Bureau, so in writings to observe the corrupted people, okay, to find out the corrupted people, they are using some of the chemical. The most widely used chemical derivative is phenolphthalein. So on notes they applied phenolphthalein powder. If you touch those derivatives, immediately powder molecules or those traces or stick on the fingers. If you add some base like soap water or any sodium bicarbonate related solutions, whatever it is, okay. So less basic compound related solutions, if you poured on fingers, then it can be converted into pink. If you added excess amount of excess amount of basic derivatives, then pink turns to red, okay. So that's why they used red handedly. So we catch the concerned person red handedly. The terminology red handed, the terminology actually coined by the reaction of phenolphthalein, especially in the presence of base, So that's why guys, here the correct option is when phenolphthalein is added to vinegar. Vinegar means it is an acid, CH3COOH, CH3COOH. So 4 to 8% acetic acid is called as acetic acid. Acetic acid is called as mostly vinegar. It is a food preservator. So of course we already know that in presence of acids, what is the color of phenolphthalein? Mostly colorless. That's why here the correct option is option D. Suppose instead of vinegar, if they mention sodium hydroxide or potassium hydroxide, then the color of phenolphthalein turns to pink only, okay. So here it is, in presence of acid colorless, in presence of base or alkali. Generally alkali means nothing but basic nature, right. So these are the different indicators. Of course you can observe that. You should also by heart some of the indicators. Thymol blue, okay, in presence of acids its color would be red. Next one, in presence of base its color would be yellow. Next one, methyl orange, in presence of acid red, next base yellow. Next bromophenol blue, in acids yellow, in base blue. Methyl red. Next in presence of base yellow. Mostly if you use methyl red. Next methyl orange. These two indicators exhibit the same colors when we changed acids and bases, okay. Right. So next one, phenolphthalein. Phenolphthalein in presence of acid colorless, but in presence of base it exhibits pink color. This is the range of, okay, this is the color range of those concerned derivatives now. So mostly strong acids. Strong acids means pH value is in between 0 to 3. So when we add the concerned indicators, it always shows red color, okay, like methyl red or methyl orange, whatever it is. Next one, suppose if you add if you consider weak acid means 3,2, its pH value is existed in between 3 to 6 only. So mostly it shows yellow or orange color. Suppose if we consider neutral, it exhibits green color. If it is in between 8 to 11, means weak alkali, it shows blue color. If it is in between 11 to 14, mostly it exhibits violet or indigo color. It indicates the nature of the base is strong, okay. So this is the representation of, this is the importance of universal indicators. If you add universal indicators, mostly we can get these type of colors based on the pH ranges. Next one, when washing soda reacts with hydrochloric acid, dash gas is evolved. Washing soda, nothing but Na2CO3, sodium carbonate, okay, sodium carbonate. It has 10 water molecules. When we add hydrochloric acid, so guys, if you consider carbonates or bicarbonates, okay, sodium bicarbonate or potassium bicarbonate, whatever it is. So if you add acids, mostly acids to bicarbonate or carbonate, it evolved only carbon dioxide, okay, carbon dioxide along with some water molecules also, but here they mention only carbon related derivatives na. So option C is the right answer. This is fire extinguisher. It means by using these derivatives we can control the fire accidents, okay, that is the meaning of fire extinguisher. This is the most commonly used fire extinguisher, of course you already know that. if you observe red color cylinders, okay, red color cylinders mostly in shopping malls, at the same time cinema theaters, movie theaters, next hospitals, whatever it is, okay, mostly in colleges also. We can observe some of the red color cylinders, na? So to control the fire related accidents, those cylinders are called as fire extinguisher devices. So in those fire extinguisher devices, what kind of chemical composition mostly be existed? Sodium bicarbonate along with dilute acid. Okay, so dilute acid, nothing but dilute sulfuric acid. Okay, so in those cylinders we are not directly using carbon dioxide. Okay, so but it is existed, but it is having this type of composition. So when we apply some pressure on this pin, then here one glass bottle one glass bottle is there, and at this region we have sodium bicarbonate. When we applied some pressure, mostly this glass bottle getting to be broken. So in this bottle we have dilute acid. Then this dilute acid directly contact with the sodium bicarbonate, then it emits fresh amount of carbon dioxide. So this is the conclusion about fire extinguisher related devices. Next one, what happened to wavelength and frequency of light when it is propagates from rarer medium to denser medium? Rarer medium to denser medium. Yes, let's consider air, and here it is water. Air is a rarer medium. Air is a rarer medium, and water is considered as denser medium. Okay, how can you conclude that? Based on the particles. So air, so it has less number of particles in a unit area, but in water it has bulk number of particles compared with air in unit area. That's why it is treated as a denser medium. When light is passed from rarer to denser, mostly its frequency not be varied, but here the wavelength, okay, so mostly lambda value mostly be varied, only lambda value. That's why wavelength is wavelength decreases from rarer to denser, wavelength decreases and frequency remains constant. Yes, so that's why guys, here the correct option is, so this is the phenomena, here the correct option is option C. Option C. Okay, right, next one. Methyl alcohol and ethyl alcohol differ in molecular mass by dash units. Methyl alcohol CH3OH and ethyl alcohol C2H5OH. So what is the molecular mass of methyl alcohol? Here carbon mass would be 12, hydrogen 1, but here we have 3 hydrogens na. Next oxygen 16, hydrogen 1. So finally what we get? Mostly so 20, 32 units, 32 units of mass. Next ethyl alcohol, 2 carbons, so 2 into 12. Next 6 hydrogen, 6 into 1, 1 oxygen 16, so 24, 30, mostly 46, so 46 units. So the difference between these two things, U means atomic mass unit, that is considered as the units of mostly atoms. So that is also the smallest unit of mass. Okay, AMU, atomic mass unit, is considered as the smallest unit of mass. So finally here the difference is 14 only. So the correct option is B. Next, on average a human heart is found to be beat 75 times per minute. The beaten frequency of the heart is frequency means the number of oscillations per second. Okay, the number of oscillations mostly per second, or number of vibrations per second. So here how many times mostly it exhibit vibrations? 75 na, 75 by per minute. Per minute means how many seconds? Why? Because frequency always indicates in the terms of seconds only. That's why you have to convert minutes into seconds, 60. Finally here the correct one is 1.25 hertz. Okay, so cycle per second is considered as hertz. H. Okay, so 1.2 Hz is the correct one. Option A is the right answer. Next one, each consecutive member of family of hydrocarbons differ from previous member by the dash group. Right. So suppose if you considered methane CH4, consecutive member of family of hydrocarbons, right. So this is methane and this is considered as ethane and this is treated as propane. Okay, so propane, and this is considered as butane. Okay, so butane. So guys, if you observe from here, from propane or from ethane, so what is the difference? Only CH2 na? Only one CH2 is different from the previous molecule, right? If you consider two consecutive members of carbon family, so mostly CH2 is the difference. CH2 means nothing but what we call methylene. Okay, so methylene is the difference. Methylene is the difference. Option A is the correct one. Next, tooth decay starts when pH of the mouth is. Suppose if the saliva concentration is less than 5.5, then it happens tooth decay. Of course, in our body we have one of the strongest material, that is nothing but enamel layer. Okay, so enamel layer. So this is the strongest one. So in presence of high concentrated saliva, mostly this enamel layer also get into be corroded. So that's why here the correct one is less than 5.5. If the enamel layer get to be corroded, then what will happen? Mostly we can get tooth decay or dental cavities. Next, blue shift observed in the spectrum of light emitted by a star represent. So in cosmology guys, we are using generally two terminology, one is blue and the second one is red. Blue shift means, let's consider here it is the observer, here it is the observer and here it is the particle. Okay, suppose if this particle exhibit red color, okay, if it is exhibit red color, it means it is very near to the it is very far from the observer, that is the symbolic indication. Suppose let's consider another particle, it shows blue color. So if the particle appeared blue color to this observer, it symbolically indicates it is very near to the observer. So finally, blue shift means very near to the observer, red shift means very far from the observer. So here the star is moving towards the earth, so the star is moving away from the earth, the star is at rest, next the temperature of the star is decreasing. So mostly option A is the correct one, the star is moving away from the earth, it means away from the, blue shift na, they mentioned about blue shift, right? They mentioned about blue shift means the star is moving towards the earth only. It means option C is the right answer, option C. Suppose if they mention red shift, then we can conclude the star is moving away from the earth. Here it is, blue shift, red shift. These two are completely depends upon the Doppler effect. Okay, so based on the Doppler effect, we can conclude, so the stars, mostly in our galaxy we have number of stars now. So based on the color also we can conclude where it is it near to us or far away from us. So this type of conclusion we can easily get through the concept of blue shift and red shift. Next, dash is not a covalent molecule. Covalent molecule means, mostly covalent molecule means it shares the electrons between two atoms. It is sharing the electrons between two atoms, but here they are rising about not a covalent molecule. So means nothing but ionic molecules always exhibiting ions, so +2, -2 like that. Okay, so that's why option A is the right answer. If it is exhibiting ions, mostly that is not considered as a covalent compound. Okay, so that's why option A is the right answer. If you consider remaining molecules, it does not shows any positive and negative charges na. Next, milkman add a small amount of baking soda to fresh milk. Why? Because if you are considering milk, if it is directly exposed to atmospheric gases, within small span of time it get into be converted na. So some of the chemical composition get into be converted and its taste is also be varied. Okay, so the name of the process is called as acidification. So to prevent acidification, mostly we have to add some some bases, nothing but baking soda like that. Okay, so this is the total conclusion about today's class, guys. So here we covered some of the most important concepts which concerns to light, next heat, next liquids, next in chemistry also periodic table, next some of the basic concepts. Okay, so some of the classification of elements, next how to estimate the or how to identify the valency electrons. So the concern concepts, almost all these things we covered in this section. So please go through the each and every question, and you have to definitely get the good score if you follow these videos, right? Thank you. I wish you all the best. Have a nice day.